there is a type of experimental design that appears to be two populations, but it's actually just one, and that's the matched pairs design. So just as a reminder, there's two different interpretations of matched pairs. I've copied and pasted what we had previously discussed, but the idea is that since we are effectively matching either two closely related people, that's effectively the same person, or again taking one person through both treatments, that's only one population. But so how we do this, or how we conduct the t-test with this, even though there are seemingly two populations, is that we try to find the difference between the responses within each pair. So if we have like a before and after, or a treatment 1, treatment 2, we take the difference in some specified order and then apply the T procedures to those differences. Okay, so here's an example, a little technical, but it's looking at a measure of vascular stiffness in children with progeria. Okay, and you can read the context, but there's an Excel file that we're going to see that has the before and after, or the treated and untreated context, or the treated and untreated methods, and all we have to do is determine if there's evidence that the 2-year treatment was, or if the 2-year treatment lowers PWV. So when we look at this, we're going to say, you know, mu, let's say mu2 is equal to average PWV level at end of 2 years. And then we're going to look at mu naught, which is average PWV level at end of, or at beginning, I'll say. And so the difference that we're going to compute, mu d, I'm going to call it, is mu2 minus mu1, or mu0. Okay? And so the hypothesis test that I want to set up here is that the default idea would be that that mu d, this difference, would be nothing, right? There would be no difference between the two levels, before and after. But hopefully what I'm seeing is that at the end, we should see lower PWV. So if I think about this difference, it should be a negative number. Okay, so this is the hypothesis test that I'm going to run, and we'll capture things along the way. We will need to get this t statistic still, so we'll need, you know, x bar mu naught here is just going to be 0, s n is going to be 18, and then it didn't give us an alpha value. We'll just use a 5% significance level for this one. Okay, but let's take a look at the Excel file. Alright, so here we can see that there's this untreated column, which would be that baseline that start at the start at year 0, and then after 2 years, here we go. Okay, so the first thing I need to do is I need to calculate a difference, right? And so to do this, I'm just going to say, okay, take the treated value, subtract the untreated value. I want to cell reference. I'll show you why, because if you click on this, rather than do this 18 times, right, there's this little black box in the corner. If your cursor should change from a white cross to a black cross with no arrows. If you double click on that, or you can click and drag down, it'll calculate all the differences for you, all in one fell swoop. Very nice. Okay, but okay, now we need to run the t-test, right? So I need x bar, I need s, I need n, which I know is 18, and what else do I need? Oh, I need mu naught, which I know is 0. Okay, so let's calculate these for the differences. So average of the differences, sample standard deviation, st dev dot s of the differences. Okay, good. And now I want my t-test statistic. Okay, and so for this, again, I do the x bar minus mu, divided by sigma, or actually s, rather in this case, divided by square root of n. Okay, whoa, super tiny. P-value is going to be super low. Remember that the t-distribution, its mean is zeros, and it roughly follows the standard normal, so yeah. And then this is my p-value. So this is t dot dist this, and then degrees of freedom would be 18 minus 1, or 17, and then true. Okay, there we go, super tiny, right? So we really reject the null, and we say that there is evidence that the difference is less than 0. Okay, so I'm just going to say since p, which is very tiny, right, is less than alpha, we reject the null. There is sufficient, or based on the data, based on the data, there is sufficient evidence that the treatment lowers PWV levels. Okay. Again, I could state it as that the average with the treatment after 2 years is lower than the beginning mark. I could say that, but it effectively translates to the same thing. Okay, so either way it works, and then you could go on from this if you wish, but this is enough for right now. Okay, so again, matched pairs design, the idea is establish some pre and post, or placebo treatment idea, calculate the differences, and then look at the mean difference for that and set your hypotheses up in reference to those mean difference, or in reference to those differences.